In this Group 2 video, I'm going to look at the reactions of some Group 2 compounds. So we'll start with the oxides and hydroxides of Group 2. They are both bases and therefore will react with acids to form a salt and water. So we'll look at a couple of examples now. So calcium oxide and hydrochloric acid, remember it's acid and base, salt and water. So which salt will we get? Well, we'll get calcium chloride. Calcium forms a 2+ ion, chloride is just 1-, and so the formula of the salt will be CaCl2. And obviously we need water in there, and that's aqueous, and obviously that's liquid. So to balance this we need 2 chlorines, so there's going to be a 2 in front of that, and I think, yep, that's it. The magnesium hydroxide, so I'm using magnesium hydroxide in the solid form here, and aqueous sulfuric acid. Again, we're going to get salt and water, so we'll get magnesium sulfate as the salt, so this metal ion is going to replace the H+ ions to form the salt. So it's MgSO4, because we've got 2+ and 2- in this salt, and water again. That's aqueous, and that's obviously liquid. In terms of balancing, we would need, it looks like 2 waters there. In terms of observations for both of these reactions, again, state symbols is gives you a big clue. Solids, aqueous, aqueous and liquid, so the solids dissolved. If we look at how the oxides and hydroxides interact with water now, so we'll start with the oxides. These actually react with water, and I've chosen the magnesium oxide reaction for the video. So you can see there that solid magnesium oxide reacts with water to form an aqueous solution of magnesium hydroxide. Remember, these things are bases, and so therefore the pH of the solution is going to be reasonably high, so in the order of sort of 10 to 12. The hydroxides readily dissolve in water, and so hydroxides are alkalis. Remember, alkalis are soluble bases, and the example I've chosen here is calcium hydroxide. So if you took some calcium hydroxide, solid calcium hydroxide, and popped it in some water, it would basically just dissociate into its ions, which are Ca2+, so you'd have aqueous Ca2+ ions in there, and you'd have aqueous hydroxide ions in there as well. And obviously these ions here are the ions responsible for the pH being quite high, so again sort of pH in the order of 10, 11, 12. You can see I've written in black there, the hydroxides of group 2 actually become more soluble as you go down the group, and as a result of that the solutions become more and more alkaline, and that's because if these are able to dissolve more easily, there's going to be a higher concentration of the hydroxide ions in the solution, and remember, it's these that make the solution alkaline. We'll look at the group 2 carbonates now. So the first thing is the fact that they neutralise acids, and when they do react with acids they'll make a salt, water and carbon dioxide. So we'll do a couple of examples now. So we'll look at the reaction of calcium carbonate with nitric acid first. So solid calcium carbonate is going to react with aqueous nitric acid to form the salt calcium nitrate. So that will be CaNO3 twice, and that will be aqueous. Remember, 2 + 1-, so you need 2 of these for every one of those. H2O, liquid, and to squeeze in CO2, and obviously that will be gas. And to balance that equation, we need a 2 in front of the nitric acid. The magnesium carbonate would react with hydrochloric acid to form the salt magnesium chloride. So that's going to be MgCl2, 2 plus 1 minus each. That will be aqueous. And we also get water, liquid, and CO2 gas. And to balance this, 2 chlorine, 2 HCl's. Observations, again look at the state symbols, solid, aqueous, aqueous, liquid, gas. So the solid's dissolving in both examples, and the extra observation in here is you would see gas produced. So you'd see bubbles of gas or effervescence. The other group 2 carbonate reaction that we need to know about is what happens when you heat them up. They break down when you heat them, and obviously this is an example of thermal decomposition, broken down by heat. So there's the example I've chosen for the video, calcium carbonate. When you heat that up, the solid calcium carbonate turns into solid calcium oxide, and CO2 gas is also produced. Now there's a trend that we need to be aware of for this reaction, and that is that they become more difficult to decompose as you go down the group. So more and more heat is required to break them down. Another way you could say that is the ease of thermal decomposition decreases down the group. The reason for that, if you're interested, it's not tested, but if you are interested, it's due to the increasing ionic character as you go down the group. So I'll just quickly explain that with these two diagrams here. These metal carbonates are made up of the M2 plus ion and the CO3 minus ion, the carbonate ion. As you go down the group, the radius, the M2 plus ion, gets bigger and bigger and bigger, and what it ceases to be able to do less and less is polarize the carbonate ion. So if you think about the ion at the very top of the group, so that would be beryllium carbonate, you've got a tiny little Be2 plus ion, which is very highly polarizing, and therefore it can sort of distort the electron density and sort of make it like oval shaped there, and that gives it some covalent character, and that weakens the attraction between the two ions and makes it slightly easier to break down. As the metal ion gets larger, it becomes less able to do that, and so you get increased ionic character, true ionic character, and therefore the stronger ionic bonding between the ions in the lattice. We'll just finish with some uses of group 2 compounds. So I'll start with the oxides or hydroxides. Reminder that they are bases, and therefore you can use these chemicals to neutralize acids. So a couple of examples: calcium hydroxide is used in very large quantities to reduce the acidity of soils that are too acidic, and obviously that wouldn't be good for the crops that are growing in those fields. So calcium hydroxide reduces the acidity of soils. On a smaller scale, magnesium hydroxide would be used in things like indigestion remedies. So if you've got a buildup of stomach acid, you take something like milk of magnesia, which contains magnesium hydroxide, and that would help to reduce the acidity levels in your stomach.